Hello and welcome. In today's video, I'm going to walk you through the process of installing the reference implementation of the ODA Canvas. We'll cover everything from the software versions of Kubernetes that it supports, to the types of deployments and the prerequisites you'll need. I'll show you how to test your Kubernetes environment, perform a simple installation using a Helm chart, and provide some helpful options and troubleshooting tips. Let's get started. So if you go to the GitHub repository for the ODA Canvas, you'll see there's an installation guide. If you want more information about what is the ODA Canvas, there's also on that homepage a short video of an introduction to the ODA Canvas. But for today's video, we're going to go through the installation guide. So the reference implementation of the ODA Canvas is a set of Helm charts that can be used to install and configure a fully working canvas. And the reference implementation is built on top of Kubernetes and Istio. Now, in the future, if you build your own ODA Canvas deployment, you're not mandated to use Istio. You could use a different service mesh, but the reference implementation is built upon Istio. The reference implementation, there's been multiple versions of the actual ODA Canvas, and we're now on V1. And for each version, it shows what versions of Kubernetes, or the range of versions of Kubernetes, that we've tested against. And you can see for V1, we've tested from Kubernetes version 1.22 to version 1.30. If you're connected to an ODA Canvas which is already installed, there's a command here which will show you what version you're on, and it'll actually show you all the versions of components that canvas supports, and we're going to use this command later on once we've installed the canvas. We've also tested on a number of different Kubernetes distributions, and this table shows the different Kubernetes distributions we've tested on. Now, this isn't exhaustive, this is just the one that the community has actually exercised so far. There is an issue if you want to test it on a different Kubernetes deployment. I suggest you add to this issue, and we would welcome any contributions of showcasing that it works on other distributions. Now, I know that there are people currently working on testing against OpenShift, so this table I expect shortly OpenShift to be in the table. Now, as I mentioned, the reference implementation uses Istio. This is the version of Istio we're using, and we also package the canvas itself as a Helm chart, and this is the version of Helm that we're using. For the reference implementation, we also use these prerequisites. So we are using Keycloak as our identity management platform, and Keycloak itself uses Postgres database. And again, these are part of the reference implementation. In your own canvas, you might use a different identity management platform. The reference canvas has very small hardware requirements. You can run it on a development machine, and I'm going to showcase today installing it on my own development machine. It only needs a moderately capable desktop computer to operate. And in terms of the prerequisites, so I've already got installed on my machine a distribution of Kubernetes, so I'm actually using Docker Desktop for Windows, and I've already installed Istio. Now, as part of the prerequisites, we include this nice script, and this is a test that I've got all the appropriate permissions I need to install it. You don't have to execute this. This is just a test which will show me that I've got the right permissions in place. If I copy that, here is my local command line tool. If I paste that, it'll just go through and it'll just confirm that I have the appropriate permissions, so I should be able to go ahead and install the canvas. Now, on my own machine, I've already got Helm installed. It shows the instructions for installing Helm if you don't. And I've already got Istio installed, and it shows the instructions for installing Istio. So to start this installation, all you actually need is a Kubernetes distribution within the supported range. There is an optional prerequisite, so the reference canvas supports a secrets management vault, If you want to use the reference one, it uses HashiCorp Vault. And again, your own canvas could use any mechanism for secrets management, and it's not a mandatory part of the canvas. So I'm actually not going to install this now, but if you wanted to have a canvas with the secrets management capability, you install HashiCorp Vault. Now on to the actual installation. So the installation is very straightforward. You don't even have to clone the GitHub repo for the ODA Canvas. You can just, using Helm, you add the Canvas repository into your Helm chart repository and do an update. So these two commands I'm going to run. So this is adding the ODA Canvas as a Helm chart repository. So now Helm knows about the ODA Canvas. And then to install the reference implementation, there's just a few notes here about when it installs it. In the reference implementation, there are 3 options of API gateway, and I'll come on to show how these work. By default, this is how it's configured. It's configured to just use the Istio service mesh as the API gateway. It's not a true API gateway, but it is a way of exposing APIs in a very simple way. If you wanted to install one of the reference gateways that are part of the reference, you just need to change these properties in the values file. And again, there are other API gateways that have been tested against the canvas. In the reference implementation team, these are the 3 that we are going to maintain going forward. So I'm just going to leave that as the default. So to do the actual installation, it's just one single Helm command, Helm install canvas from this Helm chart repo that we referenced earlier, and I'm going to call the canvas namespace canvas, and I'm asking it to create that namespace as part of the install. So it's actually the installation is a single Helm command, and if I run this, it will take a couple of minutes to install, and I'll fast forward the video. So you can see just from the timestamps in my console window, it took approximately 3 minutes to install the canvas. It was deployed successfully. I can do a quick test that it has been deployed. So as I mentioned earlier, there is a command which will just tell you which version of a canvas you're running, or really it's which version of components you support. Just run that. And this is showing the canvas I've just deployed. It is the latest version, so it's a V1. But the V1 canvas will support components of V1, V1 Beta 4, V1 Beta 3, and it'll even support V1 Beta 2, and I know it'll give me some warnings. And this is where we talk about an N-2 in terms of the versioning, so I can deploy components of N-2, and actually you can deploy one prior to that would actually give you warnings. So the canvas has been deployed successfully. I'm now going to test it out, and the first thing I'm going to do is test it out using some of the reference example components that we've created. So I go out to the ODA Canvas repository. There is a repository of just a couple of reference example components that we've created. And again, if I go into this reference example component repository, similarly, I just add this example repository to my Helm chart repo. So it's added that to my Helm chart repo, and then there's a command to actually install a component. And so I'm going to run that command. So I'm going to say Helm install, I'm giving it a release name R1, and I'm installing the product catalog example component in the namespace components. And so this should install an ODA component in the canvas that I've just installed. And if I do a kube control command just to see the progress of that, so I can say kube control get components. And this is the key thing. So a component is now a first-class citizen in my Kubernetes cluster, and I can say kube control get components, and it's showing, yes, I have a component which is release name R1 and then product catalog management, and you can see it's now in this in progress deployment state. and I give it a few seconds. In a few seconds it'll go through to being fully deployed. So now that component is fully deployed, and so for example I can ask it, that component presumably was exposing some APIs, and just as component is a first-class citizen, I can get the APIs because they're also first-class citizens. And so I can similarly do kubectl get exposed APIs, and it's showing me that my component, slightly smaller, my component R1, it actually has 4 different APIs. It has metrics, which is for the observability. It has this party role API for how it manages roles. And there's a product catalog management API, which is not surprising because this is a product catalog component. And it also implements the promotion management API. And you see from this that the implementation is all ready to receive traffic. And it's showing me that this is the URL where I can actually interact with that API. And I'll test this out locally, so I'm just going to use Postman to test this out. I've got a Postman environment here. And in my Postman, I've got some component tests, so I can do things like get categories. I've got this configured against my local Kubernetes cluster. So the host name is just my local host. And if I run this, I should get an empty list because this is a brand new component. If I go and create a category as an example, so I'm creating an internet line of products category, and I'll create a second category, an IoT line of product category. So I've created 2 categories. If I now go and do the get categories again, it shouldn't be empty. I have these 2 categories that I've just posted to it. So my component is there, it's working, I can interact with it through the API. I also wanted to show the fact that the identity was automatically configured as part of the process. So if I get rid of this, if I go into keycloak, so I go localhost. So this is the keycloak which was installed as part of the installation. And if I go into the keycloak admin console and sign in, then what you'll find is there's a realm called ODA RI for reference implementation. And in this, it should have created a client for my component. So when you deploy a component, it automatically will configure that component as a client in keycloak. And so I should find there is a client in here. And here it is. So there was a client for R1 product catalog management. So this is automatically created as I deployed that component. And in that, I should see any roles that this component asked to be included into the identity management platform. And here it is. So like initially it just has a single admin role that you can use to interact with that component. So this is a demonstration that in one command I installed the ODA Canvas, and then I was able to, in one command, install an ODA component, and that component automatically configured all the API exposure and automatically configured the roles that you require if you want to interact with that component. So the installation of the ODA Canvas is very straightforward. This is the reference implementation, and you should be able to get up and running very quickly, even if it's on just a local development Kubernetes cluster. Okay, I hope that was useful. Thanks for your time.